This is our circuit for supply system for delta connection. Here we are talking that in case the three-phase delta load is connected, so the current IY, IR and IB, which are the line current, will flow from the supply system towards the load. Okay, is this clear? So this is the line current, and so what is the difference between the star system and delta system if we compare? In the star system, the single letter or subscript was used for phasor quantities. Okay, like we have used ER, EY and EB. So at that point, that ER, EY and EB were the phasor EMF, okay, of R phase, Y phase and B phase. Here that voltage is replaced by current and phasor quantity is replaced by line quantity. Okay, so here this IR, and they in this star system it was ER, EMF of R phase. EMF becomes current here, so it becomes the, and phasor quantities become the line quantity. So it is the line current of R phase. Okay, so it is also represented by phasor diagram as shown. We will discuss that as well. So it is also represented by vector algebra. Using vector algebra, IYR minus IRB. Okay, so this diagram is shown. So how to draw this diagram, we will study this as well. So here this EMF direction is anti-clockwise. Okay, so first of all we will draw the line currents which are separated 120 degrees apart. Okay, so this is our R phase. Say this is our Y phase. Okay, just a minute. This now it becomes good enough. So okay, so this is our line current representation of R, line current representation of three system. So these are the line current. So now this is IYR plus minus of IRB. So it will constitute the IR. Okay. So again here one is positive quantity and other is negative quantity, and using the vector addition or parallelogram graph addition, we will reach to the line current values. So you can draw one positive component and one negative component. So say this is our IYR. So next component is negative. Okay. So negative component. So let us join this. So which actually means that it is here, and this is the vector addition. So this is the minus IRB component, and this is the IYR component. And we have reached to the resultant as IR. Okay. So one line current representation is drawn, then others can be drawn easily. One is to be assumed, positive and negative direction are to be assumed. You can also assume this as IYR, and then that is minus IRB. It can be represented that way also. Okay. But if we are taking this as one IYR, so this is positive. So by drawing equal and opposite, so it becomes minus IYR. So since this is IRB minus IRB, so the positive IRB will be equal and opposite, say like this. Okay. So similarly, now IY is minus IYR and plus IBY. Okay. So this is minus IYR. So this is minus. So plus will be in different direction. So say this is this. Then we are going to complete the vector addition. Similarly, we can draw the third part as well. Okay. Now, similarly, we will again calculate the relationship between the line current and the phase current. So this is the IYR, and this IR, sorry, this is IR. We will use this formula and use the formula a square plus b square plus 2ab cos of angle between them. Okay. So what is the cos of the angle between them? It is cos 60. This is the this and this angle. Okay, this is 60 degrees, and it is substituted. Okay. Again, there is a word of caution here, that when you are writing, say, IYR square, so or minus IRB, it should be precisely written like this: minus IRB within the mod, and minus sign is to be there, arrow should be there, and square should be there. Okay. So using this, we get the relationship as line current is equal to root 3 times phase current. So it is applicable for all the three line currents. And here the line voltage and the phase voltages are same. In the star, line current and the phase current were same. Here line voltage and phase voltage will be same. Okay. And the power delivered to the load is also same. Okay. So in the single phase, we know that it is VI cos phi. In the three phase, it becomes 3 VI cos phi. Similarly, if we are calculating for line current and line voltages, same formula for apparent power, power factor, reactive power, every power is same. Okay. So since these are circulating, these EMF is same as in the case of the EMF of the star voltage of different phases. Some was 0. Here also this ERY, EYB and EBR, when they are added, it becomes 0. So it means that the no circulating current is within the mesh if no load is connected to the lines. Okay.